Following on from the previous video, we got to this stage here. We got to this stage here, but we want to rewrite this in such a way that this here is a 1, and also this whole thing here is something squared. Okay, so we would, from here, we would factor out the 9 over 2. So factor out the 9 over 2, then this will become a 1. So from here, just looking at this bit, we would factor out the 9 over 2, 9 over 2 here, and then on the inside it has to be this in order for it to make sense. It has what's left on the inside has to be this in order for it to make sense. Because if you were to multiply this out, it will give you this thing here. Okay, so we got to this stage here. But the thing is, we want it in. If you look at this here, this is a block on the outside of the squared. We want to push everything inside the square here. So because we want it in this form here, and then everything has to be squared here. So we've got to push everything inside this bubble here. But the thing is, not a lot of people know that you to push on the inside, you square root this, and then you can push it on the inside. And we got to a stage where, how is it that we know that we can push it on the inside if we take the square root? Well, if you look at this, so now I'm going to try and justify this move here. I'm trying to justify why you're able to push this in the inside if you take the square root of the top and the bottom. Okay, so let's have a look at this. So justification of the above move. Now consider this, when you have, let's just say you've got some random thing like x plus a, and then you square it. Well, this thing squared would give you this. Okay, so this whole thing here would mean this times this, this times this, and this times this. So bear this in your mind. At the back of your mind, remember this. What you've got here at the moment is this times this, this times this, and this times this. Now consider the square root. Consider the square root here. So now if you multiply this inside here, it will give you this. Okay. So the point I'm trying to make here is that this thing here is exactly the same as this thing here. Okay. So hang on. So let's try and square this. So squaring this would be this squared would give you, hang on, let me do this, hang on, bear with me. So we've got square root of b over square root of c x plus square root of b over square root of c a, and then we've got to square it. So that would be square root of b over square root of c x plus square root of b over square root of c a. Now this times this here would actually give you this. Think about it. Press pause if you have to. This times this, and then plus this times this would give you this. Press pause if you have to, but it does. This here times the last term here would actually give you this. Yeah, so hang on. So this thing times this thing here will actually give you this. You might have to press pause and think about it, but it does give you that. So if you try and multiply this out, it will give you this. And by the way, this thing here is really the same as this times this, because this times this here will give you this. This times this here will give you this. This times this will give you this. The point I'm trying to make is that if you want to push this inside here, square root, and then push it inside here. So let's go back. Let's go back one step. So we were currently here. Let's go back another step. So we were here, okay, and we want to somehow get the 1 here. So factor out 9 over 2. Factor out 9 over 2 would then give us this, and then push this inside here. That will then give us this. Okay. And by the way, this thing here is really 1 over 3. Same denominator, same denominator. So the whole thing is actually this. Okay. Just bear that in mind. So we are now here. So going back to here. Oh, hang on. We are currently well, we are now at this stage here. You can merge these two. You can tidy these two fractions up to this. Okay. So now we are here. Now put this. Hang on. Let me think. Oh, sorry. We are currently here. So we are currently here. We can now turn this into this. Okay, because we spent quite a long time getting to this stage here, but now we can put this into here to give us this thing here. Okay, so from here we can actually jump to here. Okay, and now we this thing here is a constant. Oops, hang on. This thing here is a constant, so take the constant out. So so taking the constant out is really the reciprocal of this thing here. Okay, so well, if you take this out, it will give you this. So now now this whole thing here becomes this thing here. Okay, so now if you look at this, this is in the form of 1 over u squared plus 1. Okay, so the whole thing here is being squared. Okay, so actually we don't actually need the squared brackets here. We don't actually need the square brackets here. Okay, and then so we are now currently we are here. So now now integrate it. So if you look at this, this is the exact derivative of this. So when you integrate this, it will give you the natural log of this whole thing. And then when you integrate this, it's 1 over, sorry, when you integrate this whole thing here, it will be inverse tan of this bubble here. Remember, inverse tan of this bubble here, because this is in the form of 1 over u squared plus 1. So when you integrate it, well, when you integrate it, it will give you this. But don't forget, if you look at what's inside, here, you still got a coefficient of x here. So for you to integrate it, you need to times the reciprocal of 2 over 3, which is 3 over 2. Because if you might have to think about this, but because you've got if you try and differentiate inverse tan of a bubble here, say in this bubble you've got 2 over 3x here. If you differentiate this, it will give you 1 over the bubble squared, so 2 over 3x squared plus 1, but then you've got to times with the derivative of the bubble itself, which is 2 over 3. So when you come to integrate this, you need to negate this thing here. You need to negate this thing here. The way you negate it is to times by this number here. Okay. The point is that if you integrate this, it will give you this thing here times this number here. Okay. And then this will cancel out with the 2 here, and then visualize this 9 as a 3 times a 3. So this will cancel out with this, leaving you a third. So the overall answer here will be this. Okay.